All right, don't forget we have a quiz on Friday. There is a practice quiz on the website. Quiz will be just like that. It's a 40-point quiz too.
On Thursday.
So,
Thursday too.
I think a lot of us need a big number. And they come in for help if you have questions on it.
Oh, you're not gonna do it.
But it's all homework. It's all homework problems, like normal. No surprises in this class. All right, what section are we on? I don't really know.
The most important.
Oh, 6.3 it is, 6.3.
43.
Just work.
Forget
Number 15. It says find the average value of the function without integrating by looking at the graph. Come on. Okay, so you have a graph. They give you the piecewise function, but you really don't need it. The -4 and 2, and it goes up to 3. Does it?
Yes. Yeah.
Okay, 3 at -1, so it looks like this. Okay. Well, what is the average value? What's the formula for average value? 1 over b minus a. You have to know this formula. Integral from a to b of whatever the function is dx. Now, if this is the graph of the function, then what does this integral tell you? The area between the graph and the x-axis, right? So, which is this area right there, which is a triangle. And how do you find the area of a triangle? 1/2 base times height. So what is the base? 6. What is the height? 3. So what would that be? 9. So this integral is equal to 9. You simply have to multiply it by the 1 over b minus a, which is 1/6. So the final answer is 3 over 2. Cartouche! But that makes sense, right? Because look, if you have a straight line, what's the average of all the y-coordinates of this? Well, if the y-coordinate here is 0, and the y-coordinate there is 3, shouldn't it be 3 over 2? 1.5, because it's a straight line. And then if you come down there, it'll be the same thing. It'll be 3 over 2 as well. So it makes sense that the answer is 3 over 2. Yeah, so if it's like a straight line, it's easy to compute average value, but most of the time it's not going to be a straight line. Okay, number 16. Yeah, that looks like the one we did yesterday. Okay, so here's yeah, this is the one we did yesterday. So I'll give you a boo then. Boo! There you go. So from -1 to 1, find the average value. So find the average of all the y-coordinates on this graph. So what's the formula? 1 over b minus a. Integral from a to b of whatever this function is dx. So if this is the function, this integral tells you the area between the graph and the x-axis, which is this. Can we figure out that area?
Yeah.
Yeah. Just make a rectangle and subtract the semicircle, right? Okay, so what is the area of the rectangle? It's 2 by 1. 2, and what's the area of half a circle of radius 1? Pi over 2. So all you have to do now is multiply it by the 1 over b minus a. 2 minus pi over 2. Distributize the 1/2 and you get 1 minus pi over 4. Which is about 1/4 around. So the average value would be around here somewhere. That kind of makes sense. Would be less than 1/2, right? Because if you look, if you made a straight line, then the average value would be 1/2, right? Because if the y coordinate is 0 there and 1 up there, if it's a straight line, it's going to be half of that. But then look, most of the points are below. In fact, all the points are below the y. So that's why it's going to be smaller than 1/2. 47. Multiple choice. If the integral from, gosh, I can't even read the number, 3 to 7 of f of x dx is 5, and the integral from 2 to 7 of g of x, or is it 3?
It's 3.
gosh, I can't even see, I'm that terrible, my eyesight, equals 3, then all of the following must be true except, okay, I'm not gonna write these down. I'm just gonna look at these. A, the integral of from 3 to 7 of f of x times g of x is 15. No way. We never learned that one yesterday, right? The answer is A, just by looking at it. Because look at all the other ones. Like B, is that a property of integrals? You can split it up into separate integrals.
Yes.
And 5 plus 3 is 8. And then C, can I put the 2 on the outside? Yeah, and then you get 2 times 5 is 10. And then D, that's the same thing as, if you're adding and subtracting is the same thing. So if you make separate integrals, you get 5 minus 3 is 2. And then E, you just, what happens when you switch the limits of integration? It just negates it. So yeah, there you go. Yeah.
I have a question about that.
Mhm.
So like the integral something is like the area.
The area between the graph and the x-axis.
Okay. So if you switch the numbers,
It negates the value.
why is that? Because isn't it still positive above the x-axis?
No.
Oh.
Okay, look here. Like, if you look at this integral here, from 3 to 7, let's say the f of x looks like this.
Yeah.
So the area then would be 5 then, right?
Yeah.
But what happens if you go to integral from 7 to 3
Isn't it
of
so
f of x
far?
dx? It's going to be negative 5. Because we're integrating from this number to this number. You're going from 3 to 7. Isn't that the positive direction in the
Oh,
x-axis?
Okay.
But if you go from 7 to 3, that's going this way. That's the negative
Okay.
direction, yeah? So that's kind of why it's negative. Okay, and then 49. Multiple choice. Look. Okay, you're gonna get this. This is a problem on the quiz one. You're gonna have to use your graphic calculator to compute the average value right here. So what is the function? F of x is, it says the cosine function on the interval from 1 to 5. Come on! What's the formula for average value? 1 over b minus a, integral from a to b of f of x dx, and you simply just punch this in on your calculator. But just make sure you're in radian mode now. Because if you're in degree mode, c'est la vie, you lose half the points. Yes?
This doesn't say that we can use a calculator though.
Okay, I challenge you to do it without. Wait. Where does it say that?
It doesn't say, but
Yeah, I know, but look at all the answers are decimals.
Oh wait, no, I guess it does say
Where?
under standardized test questions.
No, look, yeah, it says, yeah, you may use a graphic calculator to solve the problem. Come on. Okay, there you go.
Sorry.
There you have it. QQ1. It says if the integral from a to a, this is just like the one I gave you yesterday. Dx is equal to a plus 2b. In fact, I recognize this problem. This was on the AP exam about 7 years ago. Then the integral from a to b of f of x plus 3 dx equals what? Well, use your properties of integrals. Can I split this up into 2 separate integrals? Hi, the integral from a to b of f of x dx plus the integral from a to b of 3 dx, correct? Now we know this is equal to, because that's given information, right? A plus 2b, and what is this?
3 times b minus.
Very good, 3 times b minus a. Some of you going, say what, girlfriend? Look, what is the graph of y equal 3? Isn't that just a horizontal line like that? And if this is a and this is b, what is the base of that rectangle? Because this integral represents this area, right? B minus a, right? Right minus left. Big minus small. That's how you find the distance over here, right? So if this is b minus a and that's 3, what's the area of that rectangle? 3 times b minus a. And I will leave the simplifying to you. You guys can distribute the 3. QQ2, aha! Okay, I'm glad somebody asked this question. Okay, now, I really didn't go over this yet, but this is going to be on the AP exam, so you need to know how to do this. So basically, this expression here, QQ2, good thing we're getting this on the video too, is like this. Root 1 over 20 plus root 2 over 20 plus root 3 over 20 plus dot 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 plus root 20 over 20 is a Riemann sum for which of the following integrals? I'm going to put this book on the side here. Okay, now remember how to do RRAM? You're going to have to know that tomorrow, right? Now, do you remember when we did LRAM, RRAM, and MRAM? If the base of every rectangle is the same, didn't we factor it out?
Yeah.
You see this number that got factored out? This is the base of each rectangle. Okay, so the base of each rectangle is 1/20. And how many rectangles am I making? How many of these are there here? There's 20 of them. So if you have 20 of them, and each one is 1/20th, then that means I'm going to go from 0 to what? 1. Right? Because how far is it from 0 to 1? 1. If I divide that into 20 equal parts, okay, I'm not sure if this is really 20 equal parts, then isn't this one 1/20th, then 2/20th, and then 3/20ths, all the way until you hit 1, which is 20/20ths? Right? And then you have, so we don't know what the graph is yet, okay? But we're breaking it up into these rectangles like that, yeah? Okay, that's definitely not 20, okay? So the base of each rectangle is 1/20th, that's what gets factored out. Now, how do I figure out the height of the rectangle? It's gonna be the y-coordinate of that point, right? If you use the right endpoint Riemann sum, right? That's what we're doing here. So, look at this. How do I figure out the y-coordinate of that point? You take the x-coordinate and you plug it into the function. Now, what does this function have to be to get this number there? Yeah, it has to be the square root of x, right? Because if you take 1/20 and plug it into there, that's the y-coordinate there. Square root of it. And then the next one, the next rectangle, what is the height? Isn't it the y-coordinate of that point? How do you find that? You take the x value and you plug it into this, that's how you get that. So therefore, this area is what? Represents what integral? The integral from 0 to 1, and what's the function? Square root of x dx. Okay, I'm going to give you a problem like this on the test. Don't worry, it'll be on the practice test. Okay, so how can this thing change? What can change here? Well, let me ask you this. What if I changed it from 1/20? What if I made 30? Yeah, so what if I went 30 over 30?
Still 1.
Yeah, it's exactly, it's the same integral. All I did is break it up into 30 rectangles instead of 20. That's the only difference. Yeah.
I think the answer was C, but then the answer for C was not what we got.
This is the answer.
Oh, that's E on the thing.
That's the answer then.
Oh, wait, no,
We
it's
don't
not
have
E.
E.
It's not.
That's
It's not. It's D.
That's okay. Whatever it is, that's the answer.
It's B? It's B.
Okay, let me look. Yeah, it's B. I see it right there. Oh, you guys have different editions.
the
No,
answer
it says C.
thing. In the textbook says C. No. Wait. Yeah.
This is the answer. Because look, okay, I gotta erase again. Go back to the original.
Check the rating on this, because that's a good indication.
The what thing?
Oh, they were talking about Slater. Ooh.
So you looked up Slater, and then it said the answer is C.
Just to check the words. Yeah.
I'm telling you what the answer is. That's it. Okay, so what was the question, Charles? You got a question about this?
Yeah, how come the 120 is?
This 1/20th represents the base of each rectangle. Because how do you find the area of a rectangle? Base times height, right?
Right.
So since each rectangle has a base of 1/20th, we factor it out. Remember, didn't we do that when we did RRAM, LRAM, MRAM? You factor it out. That's just the base of the that's like a hint that's telling you the base of each rectangle is 1/20th. And these are all the heights. This is the first height, the second, the third, the fourth, the fifth, all the way until you hit the 20th height over there. So yeah, so they're trying to trick you. There is no 1/20th out here in the front. That just represents the base of the rectangle. So how can this change? Well, instead of square root of x, Oh, I'm giving it away right there. What if I did this? What if I cubed each one? How is that gonna change? Yeah, that just means the function was x cubed, right? Instead of square root x, you get x cubed, because if I plug in 1/20th into that, don't I get this? Yeah. If I plug 2/20ths into that, you get this one. Those tell you the heights of the rectangle. Just remember, the area of a rectangle is base times height. You have to have a base and you have to have a height. This is the base, and these are all the heights. Don't worry, I'll give you a practice one soon. It's not gonna be that hard. And for some reason on the AP exam, they always do a right endpoint Riemann sum. It's always the right endpoint, so it kind of makes it easier. Okay, so let me ask you this. What if I change this to, what if I change that to 60 over 20? What's gonna change?
It's to 0 to 3.
Yeah, very good, then it's gonna go from 0 to 3. Because 60 over 20 is 3. That's like your ending point, yeah? So there's only so many things that can change in this kind of problem there. So is that the last question? Yeah, you guys are pretty good. All right, now today we're gonna learn the most powerful theorem there that you're gonna probably experience in your lifetime.
May I go to the restroom?
Yes,
I'll be fast.
okay, go ahead. That's okay,
Yeah.
yeah. Now, today we are going to learn the fundamental theorem of calculus. Unfortunately for you, it comes in two parts, part 1 and part 2. Part 1. Now, it's easy. I'm not going to prove these things because we're AB, right? You just got to be able to use them. Okay? So here's the fundamental. Now, the higher up, see, you guys are only used to functions like this, yeah? You guys are used to functions that look like this. X e to the negative x. Or maybe you're not used to that kind of function. Sine x plus cosine x. Okay, here, I'll give you an easy one. F of x is x cubed plus 3. But the higher up in math you go, the more and more functions are defined by integrals. Like for example, like if you're taking physics C or some, you go to college, you take more physics or chemistry, maybe, then you're gonna see functions that look like this. Y equal to the integral from 1 to x squared of a square root of 1 plus t squared dt. That's what a function's gonna look like. A function is defined as an integral. So like over here, look. Okay, what if this function here? What if I ask you to find f of 1? If this is the function, what would you do? You plug in 1 for x, and you get 1 cubed plus 3, which is 4. You can do that. So in this one, if you have a function that looks like this, what if I ask you to compute y of 2? You plug in 2 for x, so you get the integral from 1 to 4 of the square root of 1 plus t squared dt, and that can be punched in on your calculator, right? And you get a number.
What is T?
And you can, t is just a variable.
Okay.
Yeah, well, see, when you punch this in on your calculator, you would use x, because that's the way it is on your calculator, yeah? But it's just a number. It's a number that represents the area between the graph and the x-axis, right? That's all it is. It's a number, and then you can plot that point. So you can plot a whole bunch of, and you can actually plug this in there in your calculator like this, and it'll actually draw you the graph. Okay? So the thing is, the higher up in math you go, the more and more functions look like that. So if you want to analyze a function, like computing the maximum and minimum, or find points of inflection, what's the procedure for finding maximum and minimum points? Okay? Take the derivative and make a number line. So how do you take a derivative of a function that looks like that? Well, that's where the fundamental theorem of calculus part 1 comes in. So here it is. If y is equal to an integral from any constant to some function of g of t dt, you know what? I'm going to switch it. I'll put this one as g and that one's f. Then to take the derivative of it, all you have to do is take this thing, plug it into that function there, f of g of x, and then the most important part, times it by the derivative of that, which is g prime of x. That's the fundamental theorem of calculus part 1. All it does, it tells you how to take the derivative of a function that looks like that. That's all That's all it is. And it's really, it's ridiculously easy. You just have to get used to it. Okay, so look, here's a function. How do you take the derivative of it? Well, you use the fundamental theorem of calculus part 1. So what does it say to do? So the first thing you gotta do is you gotta make sure the lower limit is a constant. Is it a constant? Is 1 a constant?
Yes.
Yeah. Okay, so what does it say to do? You take this and you plug it in there for t. So what do you get? What happens when you plug in x squared for t right there? You get the square root of 1 plus x to the 4th, and then the most important part. Then you gotta times it by the derivative of that. 2x. Boom, that's the derivative. Now you can make a number line. Really? Question?
So x is still the independent variable.
X is the independent variable, but see, the reason why they put t's here is because they don't want you to get confused with the variables. So we call this like a dummy variable.
So
It can be anything, it doesn't matter what the letters are.
So t really doesn't matter.
Well, it's not gonna matter after you take the derivative.
Okay.
Okay, so let's just do some more examples so you get used to it. What if y is equal to the integral from -2 cosine x 1 over t dt? How do you take the derivative of this? So the first thing you gotta make sure is the lower limit a constant. Yeah, it can be any number. As long as it's some number, you can use the fundamental theorem of calculus part 1. Now what do? You take this, plug it in there, and you get 1 over cosine x. But then you gotta multiply it by the derivative of that. Negative sine x, and then of course you simplify your answer to negative tan x. Sine over cosine is tangent, right?
So the starting, no, the bottom number doesn't matter at all.
It doesn't matter as long as it's a constant though.
What
It can be any number, it can be 0, -2, pi, or radical 5, doesn't matter. As long as it's a number. So you guys think you're good now?
No.
I think you do. Y equals the integral, let the, e to the 2t to 5 sine t dt.
You can't because you have to do negative.
Okay, very good. You need the lower limit to be a constant. Yeah, but Mr. Park, the constants stay on the top. Well, what did we learn yesterday? Yeah, if you switch the limits of integration, what's so hard about this? You negate the value. You can switch the limits anytime you want, but you just gotta negate the value. Now I can use the fundamental theorem of calculus. So to take the derivative, that's a constant, throw it on the side like an unwanted pet. And what does the fundamental theorem of calculus part 1 tell us? You take this and plug it in for t here, and you get sine of e to the 2t. But then the most important part, you gotta multiply it by the derivative of that. What is the derivative of e to the box?
E to the box.
E to the box times the derivative of box. And then now, no, you wouldn't leave it like that. Come on, you should put it in the front, right? Nobody puts it in the back. Although I did see people writing x2 instead of 2x. What is that? The coefficients go in the front. The coefficients in the back. Isn't that easy?
Yeah.
Fundamental theorem of calculus part 1. All it does, it tells you how to take the derivative of a function that looks like an integral. That's easy. You just mechanically do it. All right, now, here's the most important one though, the fundamental theorem of calculus part 2.
I thought it was just part 1.
Yeah.
No. Now, the fundamental theorem of calculus part 2 allows us to actually compute integrals without actually having to use your calculator. You can actually do it. So, the integral from a to b of f of x dx. Now, to compute this integral, all you have to do is capital F of b minus capital F of a, where capital F prime is equal to f of x. There you can state the theorem very shortly like that. But what does it mean? So to compute any definite integral, all you have to do is find capital F, plug in the top number, plug in the bottom number, and subtract. But what is capital F? Well, if I take the derivative of capital F, you have to get this. So it's the antiderivative of this thing here. So, like I was telling you before, you have to be able to compute an antiderivative. But in order to do the derivative backwards, you got to be able to do the derivative forwards. Okay, so let's look at some examples. Let's do an easy one. What's the integral from 1 to 4 of x squared dx? Now, it's important to know that, yes, it's important to be able to compute it, but you got to also understand what it represents. What does this integral represent? Area. So here's y equal x squared from 1 to 4. I'm going to make it. So it represents that area, right? Okay, so how do we do it? We have to find capital F. That's the antiderivative. So what function do I have to take the derivative of to get this? Well, how do derivatives work? You put the power in the front and you make the power one smaller, right? So if you go the opposite way, you got to make the power one bigger. So the power got to be one bigger. But then when I put the 3 in the front, I have to get 1. So you need a 1/3 in the front to cancel out that 3. Is that the antiderivative?
Yeah.
Well, that's an antiderivative. The antiderivative is plus some constant. Because think about it. If I take the derivative of this, yes, you will get that, but that's not the only function you can take the derivative. What about plus 5? If I take the derivative of this, will I also get that?
Yeah.
Yeah, because the derivative of 5 is 0. What about minus 7? Yeah, so you don't know what that constant is, so that's why in calculus, we just put plus c, plus some constant. Because when you take the derivative of any number, you will get 0. Okay, so now what do? We're going to plug in the top number, the bottom number, and subtract it to that. So this is how we write it. This is standard notation. So what you do is you write down the antiderivative here, you put bracket, you put these limits here. Now what this means is you're going to plug in the top number into here. What do you get? Plug in 4 into this. 64/3 plus c. And then you plug in the bottom number, 1/3 plus c. And what do you notice about the c's? They cancel out. So basically you get 63/3, which is 21. This area is exactly 21 square units. We don't even need a calculator anymore.
Wait, how do you get 64?
Plug in the top number. 4 cubed is 64, right? Yeah, so once you find the antiderivative, you simply plug in the top number, plug in the bottom number, and subtract. Isn't that a pretty powerful theorem? And that tells you the area.
Wow.
That is pretty powerful.
Yeah, so now the question is, you gotta know how to compute antiderivatives, which means you gotta know your derivatives.
So now I am a calculator.
Okay, so here we go. Here, we did this one before. Remember Archimedes?
Oh no.
What?
Yeah.
Okay, right there. The arc, remember parabolic arch? Archimedes said the area is 2/3 baseline size. But we don't need to memorize the formula anyway. We're going to use calculus now. What integral represents this area right there? The integral from, where's here and here? What are the x-intercepts? -2 and 2 of 4 minus x squared dx. So this integral represents that area. Okay, now how do I compute an integral? Using the fundamental theorem of calculus part 2. You find the antiderivative of this. Okay, what's the antiderivative of 4? 4x, right? If you take the derivative of 4x, you get 4. What's the antiderivative of x squared? 1/3 x cubed. You make the power 1 bigger, and you put the reciprocal in the front to cancel it out, right? Plus c, and then we're going from -2 to 2. So all you have to do now is plug in the top number, bottom number, and subtract. So what happens when I plug in 2? 8 minus 8/3 plus c. Now plug in -2. -8 plus 8/3 plus c. The c's cancel out there. Are the c's always going to cancel out?
Yes.
Yes, they will. The c's are always going to cancel out. So what's left? Can I cancel out this 8 and then negative 8?
No.
Don't you dare, because when you distribute that minus sign, that's actually a plus 8. So that's actually 16 minus 16 thirds. Make a least common denominator, so that's 48 minus 16, 32 thirds. Boom! That area is exactly 32 thirds square units. Wasn't the answer, wasn't that the same answer we got last time?
Yeah.
When we did 2/3 base times height?
Wow.
Yeah.
That's pretty powerful.
Okay, here we go. Let's do it. We just gotta keep doing it until you guys get it. Okay, here's the graph of y equal cube root of x from 0 to 8. Compute this area. That's an ugly 8. What integral represents that area? The integral from 0 to 8 of whatever the function is, dx. Okay, so how do I compute this? Well, this is the same thing as x to the 1/3 power, right? So you gotta make the power 1 bigger. X to the 4/3, and then you put the reciprocal in the front, so when you drop the 4/3 down, it cancels out, right? And then you go from 0 to 8. Plug in the top number. What is 8 to the 4/3? First you cube root it, and then you raise it to the 4th power. 16 times 3/4. 12. Plug in 0. You guys better get this one. 0. You get 12. That area is exactly 12 square units. Yes.
Why don't we have a C there?
Oh! How come I didn't put the plus C? Because I know it's going to cancel out.
Can we just ignore it?
Okay. You don't need to put it as long as you know it's there, but it's going to cancel out.
We don't.
Wait, I have a question.
Yeah.
So
Would it
you put
ever not?
It always cancels out.
Okay, so
Wait, how?
Well, think about it. If you put a plus C here and a plus C there, and you're going to subtract, it has to cancel out, right?
how would
yeah.
Question.
Are we ever gonna have to like state the theorem?
No.
Okay.
Oh.
Well, they're gonna, yeah. Well, they're gonna ask you questions about it.
Oh, not like.
Like here, sometimes they do this. True or false? No, no, no. Just what is this equal to? What is that equal to? And they're gonna give you like 4 choices. But we don't need choices. We just get the answer.
What is that?
Well, how do you compute an integral? You find the antiderivative of that. What's the antiderivative of that? F of x, right?
Yeah.
Yeah.
Plug in the top number, plug in the bottom number, and subtract. Boom, that's your answer. All you have to do is find the antiderivative, then plug in the top, bottom, subtract. It's easy. See, it's like the same thing, but it's like in a different form. Here, they did, I've seen this too on the AP exam. What if they did this? Cool, I forgot the X. What's the antiderivative of f double prime? Just f prime. Plug in the top number, plug in the bottom number, and subtract. There's the answer. Okay, but we gotta do some more. So, notice the examples I gave are all like x to the nth power, but are there other kinds of functions we learned how to take the derivative of? Yes.
Oh.
Yeah, what about the trig function?
Oh.
What do you mean, oh no? You guys,
It was sine cosine.
you know what? I need more rum. I'm gonna erase this fundamental theorem already. We know what that is. Now, this is one of the first things I told you guys on your calculator. You guys remember the answer? What is the area under one hump of the sine curve? Yeah, you know it's 2. But can we get that without a calculator? Yeah, now we can. What integral represents this area here? The integral from 0 to pi of sine x dx. Okay, so in order to compute this integral, I need to find the antiderivative of that.
Negative cosine.
Very good. Negative cosine x. Think about it. Plus c, but I'm not going to write plus c because we know it cancels out. Everybody see that? If I take the derivative of this, do I get that? Yeah, because the derivative of cosine is negative sine. That's why you need a negative there to cancel out the negative. From 0 to pi. Okay, plug in the top number. Oh gosh. 1. Right? Because cosine of pi is negative 1. Negative 1 is 1. Plug in 0.
One. I mean negative.
Negative 1. 1 minus negative 1, 2. Boom. There it is, exactly 2 square units. You guys think you're good now, yeah? No, so to use the fundamental theorem of calculus, you gotta know antiderivatives. Okay, here we go. Woo! Y equal 1 over x, okay? From 1 till 4. Compute this area, exactly. What integral represents this area? The integral from 1 to 4 of whatever the function is dx. Okay, what's the antiderivative of that? Very good. Natural log x. Some of you forgot that one, huh? Remember the derivative of natural log box is 1 over box times the derivative of box? Well, if you forgot that, you're in trouble. From 1 to 4, because you can't do this, you can't do this. Oh, that's x to the negative 1. So Mr. Park said make the power 1 bigger and then put the reciprocals in the front. You can't do that. That's natural. Did you guys really forget the derivative of natural log x is 1 over x?
No.
Okay, plug in the top number, natural log 4. Plug in the bottom number, natural log 1. So what's the final answer? 2 natural log 2. 1. Well, first of all, natural log 1 is 0, right?
Oh,
yeah.
Oh, because it's e to.
Yeah, e to the what power equals 1?
Oh, 0.
0, okay. And then isn't 4 the same thing as 2 squared? So you can put the 2 in the front?
What?
Yeah.
Remember when you have logarithms, if you have a power, you can put the power in the
Oh,
front?
yeah.
See, this is how on the AP exam, they test to see if you know your properties of logarithms. Yes, natural log 4 minus natural log 1 is the answer, but that's not going to be one of the 4 choices. That's going to be one of the 4 choices. You have to know that that's the same thing as just natural log 4. Oh boy!
Yep.
Let's do some more. Here is the graph of y equal 1 over 1 plus x squared. Let's go from negative 1 to 1. Okay, what is that area? What integral represents that area? The integral from negative 1. Now, yeah, you guys know how to set up the integral. That's easy. Okay, but now, what's the antiderivative of that?
Tangent inverse.
Very good. Tan inverse x. See, that's why, if you don't know your derivatives, how can you do antiderivative? It's just like in elementary school. If you cannot do addition, how are you going to do subtraction? Right? If you don't know multiplication, how are you going to do division? Because it's just the reverse procedure, right? Do you guys remember the derivative of tan inverse x? Is that?
Yeah.
Neither? Okay, now plug in the top number. This is where you guys have problems. Tan inverse 1.
Oh no.
That means the tangent of what angles is 1?
Pi
Pi over 4. What is this root 2 business? Okay, plug in the bottom number. Tan inverse negative 1. That means the tangent of what angle is negative 1? But the answer got to be in that
What?
range, remember?
7
No,
Two
negative pi.
Negative pi over 4. How come it's not 7 pi over 4? Because 7 pi over 4 is not in the range. Some of you thinking, what are you talking about range? You've been doing this for 3. You had trig, you had pre-calculus, we did a pre-calculus review. Come on. So the answer is pi over 2. This area is exactly pi over 2 square units.
Wait, but is the range like 2 pi?
No, the range for tan inverse is from negative
Oh, yeah,
pi
that's
over
right.
2 to pi over 2. Okay, next one. Next one. Oh my goodness. Okay, here is the graph of y equals secant squared x. And what the heck? Let's go from 0 to pi over 3, like that. Okay, compute that area. Okay, now I know you can set up the integral. It's the integral from 0 to pi over 3 secant squared x dx. Okay, after this, I'm not going to even draw the picture. You guys know what it represents. It's computing it. Well, what's the antiderivative of secant squared x? Hey, see, you remembered something. From 0 to pi over 3, plug in the top number. Now we're gonna have problems, right?
No, I don't think so.
Root 3, plug in the bottom number. That's so easy.
Zero.
0, subtract root 3. That area is exactly square root of 3 square units. Okay, so now I'm not going to draw the graph anymore. Let's just compute integral. Integral cosecant x cotangent x dx from pi over 6 to pi over 2. Anyway, I'll have a hard time drawing that graph. No.
Cotangent x.
Okay, what's the antiderivative?
Cotangent.
Always
Cos-
It's negative.
No, and no. And then yes.
It's negative something.
Negative cosecant x. Some of you better stare at that. Because remember, what's the derivative of cosecant x? Negative cosecant cotangent. That's why you need that negative to cancel out the negative. Oh boy. Pi over 6 to pi over 2. Plug in the top number. Oh.
Wait, cosecant.
Cosecant is 1 over sine.
It's
So
one.
compute
Negative
sine and then flip it over.
Negative one.
So it's negative 1. Okay, what's negative cosecant pi over 6?
Is it 2? Negative 2.
Negative 2. Because sine of pi over 6 is 1/2. You flip it over, you get 2. That's a negative 2. Final answer? 1. We haven't even gotten to the hard antiderivatives yet, you know?
What is the hard? Wait, there are harder ones?
Yes. In fact, we're going to spend the rest of this semester computing harder antiderivatives. They just get harder and harder and harder.
Oh.
These are just the basic ones that are on your list.
I'm ready.
Yeah.
Okay, here we go. You guys ready for this?
No.
Too bad. 3 to the x dx from 0 to 2.
That's, isn't that 3 to 3?
Okay, this I'll give you a hint. This is the a to the u one, remember?
Yeah.
A to
So natural log A.
You're all
Wait, natural log.
3 to the x, isn't it still?
Oh, wait.
Okay, here. Let's review the derivative. Let's review the derivative. If y equals 5 to the x, what's the derivative? 5 to the x times natural log 5, right? Times the derivative of x, which is 1. So that's the derivative. So if you're going to go the other direction, antiderivative, it's going to be 3 to the x.
Over ln.
Very good. Over natural log 3. What?
Yeah, 3 is explained.
Because if you take the derivative of this, you're going to get that because this is a constant, so you throw it on the side like an unwanted pet. And the derivative of 3 to the x is 3 to the x times natural log 3. See how the natural log 3's cancel out?
Oh my god.
Oh my god.
So, no, I don't understand.
From 0 to... So are you telling me this is the hardest part, is finding that derivative?
Yeah,
Okay, then
yeah.
that, you know what that means? We need a speed quiz on the list of derivatives.
Oh.
Yes, we do. Okay, plug in the top number. 9 over natural log 3. Plug in the bottom number.
1 over
1 over natural log 3. So the final answer is 8 over natural log 3. Boom. Okay, are we ready for a hard one? Have we? No. Let's do one more and then I'll give you a hard one. Okay, integral 0 to 1/2 of 1 over the square root of 1 minus x squared dx.
No,
Okay, I heard it. Sine inverse x. The derivative of sine inverse x is that. From 0 to 1/2. Plug in the top number. Sine inverse 1/2 means sine of what angle is 1/2? Okay, pi over 6. And then plug in the bottom number. Sine of what angle is 0?
0.
Very good. So the answer is pi over 6. Easy. Oh man. No, the quiz only goes up to 6.3. This is 6.4. Don't worry, we're gonna have a separate quiz and a speed quiz on this.
What is the speed?
Believe me, even BC I had to give the speed quiz because normally they know their antiderivatives, but this year they didn't. Okay, so here's an example of a tougher one. Integral from 0 to natural log 3 of e to the 2x dx.
Whoa.
B
to the 2x.
Okay, so what is the antiderivative of e? It's not as easy as you think, you know. You gotta think about it.
1 over 2x
E to the 2x.
times 1 over 2x.
Is it just, okay, is it just e to,
1 over 2x cubed. No, square. No, 1/3.
No.
X.
Times
No,
1/2.
never mind.
times 1/2?
What?
What?
Oh, because you take the derivative.
Because, okay, how do you take the derivative of this? You throw the 1/2 on the side. What is the derivative of e to the box?
E to the
E
box.
to the box times the derivative of box, which is 2. So that's why you need that 1/2 to cancel out that 2.
Oh, that's weird.
So give us another one.
Yeah, okay, but wait, we're not even finished with this one. Okay, you guys think you're good, but you don't, just wait till, okay,
How do
now,
we plug it?
plug in the top number. Plug in the top number. Okay, what is 1/2 e to the 2 ln 3? Well, what is e to the natural log gorilla?
Gorilla.
Gorilla, okay, but, so what can I do with this 2?
Oh,
Put it up as the power. So e to the natural log gorilla is just 9. So 9/2. Okay, this one's easy. Plug in 0. E to the 0 is 1.
1/2.
So 1/2,
4.
4. Okay, I'll give you another one then. Last one. Sine 3x dx from 0 to pi over 6. Yeah, let's make it pi over 12.
Negative cosine.
Okay, what's the antiderivative of sine 3x?
Oh, 1/3 negative cosine.
Very good. Negative 1/3 cosine 3x. Well, where did the 1/3 come from? Because the derivative of the box is 3. So when you multiply by the derivative of box 3, you need a 1/3 to cancel it out. Oh, I get it, Mr. Park. So whenever the derivative of the box is like, whatever, 5, you need a 1/5 to cancel it out.
Yeah.
Exactly. From 0, but then here's the hard part for you guys. Plug in the top number.
Times 4.
3 times pi over 12 is pi over 4. Cosine of pi over 4 is root 2 over 2 times negative 1/3.
Negative root 2 over 6.
Yup, okay. Minus, plug in the bottom number. Cosine of 0 is 1,
1/3.
so you get negative 1/3, and I will leave the simplifying to you. Just make a least common denominator, right? Okay, I'll do it then. 6, negative root 2 plus 2. There you go. Believe me, the antiderivatives get tougher and tougher and tougher. You know. There is no shortcut. The shortcut is you gotta know your derivatives to do antiderivatives. That's
Are we gonna have to know how to antiderivative as the stuff?
Yes, that's coming up later.
How do you get sine x?
Question.
Oh, no, sine x, but cosine x.
Okay, the oh god, the bell's gonna ring at 1 minute already.
And then you do x.
So if you look at your homework, the homework is split into 2 parts.